In recent years, the idea of mining the moon has moved from science fiction to a serious business plan. One of the most ambitious goals comes from startups that are targeting a rare isotope called helium-3, believed to be the future of clean energy. Unlike regular helium, helium-3 has unique nuclear properties that make it an ideal candidate for fusion energy, a technology that could provide almost limitless power without the harmful waste produced by today's nuclear plants. The concept of helium-3 mining first gained global attention during the 1980s when scientists realized that the moon's surface, exposed to the solar wind, had accumulated large deposits of this isotope. Estimates suggest that there could be more than 1 million metric tons of helium-3 trapped within the lunar regolith, the dusty soil covering the moon. To put this into perspective, just 25 tons of helium-3 could power the entire United States for a year through fusion technology. The first real business step came in 2007, when several companies and even national space agencies began to publicly discuss the potential of helium-3. But it is only in the last decade that private startups, driven by lower launch costs and new technology, have begun to make concrete plans. For example, in 2022, several companies announced test missions to explore the moon's surface with robotic landers, aiming to collect and analyze soil samples to determine helium-3 concentrations. Looking ahead, milestones are being set with clear timelines. By 2026, the goal is to demonstrate small-scale extraction of lunar soil and prove that helium-3 can be separated cost-effectively. By 2030, startups plan to launch dedicated mining missions with robotic equipment capable of digging, heating lunar soil, and capturing helium-3 gas. The long-term vision, by the mid-2030s, is to transport measurable quantities of helium-3 back to Earth, where fusion research facilities are expected to be ready for pilot energy plants. The economic potential is staggering. Current projections suggest that 1 ton of helium-3 could be worth up to $3 billion, given its energy yield and rarity on Earth. Countries like China, India, and the United States have also included helium-3 in their lunar exploration plans, signaling a global race for what some are calling the oil of the 21st century. However, challenges remain. Mining on the moon requires overcoming extreme conditions such as temperature swings of more than 250 degrees Celsius, the need for autonomous equipment, and the high cost of transportation. International laws, like the 1967 Outer Space Treaty, also raise questions about ownership and exploitation of lunar resources. Despite these hurdles, the momentum is real. What makes this story fascinating is that within the next 10 to 15 years, we could witness humanity's first steps in transforming the moon into a resource hub. If successful, helium-3 mining may not only revolutionize clean energy on Earth but also finance deeper space exploration, including missions to Mars. This journey from concept to reality could become one of the defining technological milestones of the 21st century.